So this is the next question. Let me write this down. Let a differentiable function satisfy f of x positive integral 3 to x f of t over t times dt is equal to root of x positive 1 x greater than or equal to 3. Then you have to find f of 8 times 12. Okay, so this is the requirement. So let me start the solution. So we are given, what are we given? We are given f of x positive integral 3 to x f of t over t times dt is equal to root of x positive 1. Now let me differentiate both sides. Differentiation of right hand side is going to be 1 over 2 times x positive 1 raised to the power of 1 over 2 negative 1 times differentiation of x is going to be 1. So this is rewritten as 1 over 2 times x positive 1 raised to the power of negative 1 over 2, which can be rewritten as 1 over 2 times root of x positive 1. Okay, coming to the left hand side, differentiation of f is f dash of x. Now this differentiation is going to be f of x over x. Okay, and let me rewrite this again, f dash of x positive f of x divided by x. So if I were to take f of x to be equal to y, I hope you're watching it, y, then the above equation can be rewritten as, now f of x is equal to y, so f dash of x is going to be dy over dx positive f of x is y, so it's going to be y over x is equal to 1 over 2 times the root of x positive 1. Now what is this? This is a linear differential equation. So since it is a linear differential equation, we can have the integrating factor, or we can extract the integrating factor, which is e raised to the power of integral p dx. So my p is 1 over x, so therefore integral of p dx is equal to integral of 1 over x times dx, which is integral of dx over x, which is nothing but ln x. So e raised to the power of ln x will give us x. So what will be the general solution? The general solution is going to be y times what we have got, x is equal to integral x times the right hand side 1 over 2 times the root of x positive 1. This is what you got on the right hand side. Okay, so place that and we integrate this. So what I want to do to get rid of this denominator, I want to add a 1 and you take away 1 times the dx divided by 2 times the root of x positive 1. So this can be rewritten as x positive 1 divided by 2, right? 2 times, I will write the 2 out, okay, times the dx, and the next one is going to be integral dx over root of x positive 1. So this is what we have got. Of course the arbitrary constant c is there. Now how do we integrate this? So let me go and rewrite that on the next page. So what have we got? We have got 1 over 2 times integral x positive 1 into dx divided by root of x positive 1 negative integral dx divided by root of x positive 1. So what I wish to do is, I will to handle this first. let x positive 1 be equal to t squared. So dx is equal to 2 times dt. So this is 1 over 2 integral x positive 1. In place of x positive 1 it's t squared. In place of dx it's 2 times t dt. In place of x positive 1 it's t squared. So this is with the first quantity. Now for the second integral I am going to take I can have the same substitution, no harm in it. So x positive 1 is going to be t squared, so it's going to be root of t squared. My dx is 2t dt. So this is what I've got. Okay. So this can be rewritten as 1 over 2 times integral t squared root of t squared. That's t. So this and this gets cancelled. So you have a 2 there and you have a t squared times dt. Now root of t squared is t. So this and this gets cancelled. So negative 2 times integral dt. So this can be further rewritten as, see, 1 over 2 goes in, so 2 goes off. So what you get left with integral t squared dt negative integral dt. Integrate this, you get t3 or I would say t raised to the power of 3 divided by 3. Integrate this, you get t. But what is t? T squared is x positive 1. So t is equal to x positive 1 raised to the power of 1 over 2. So you substitute that. So this is x positive 1 raised to the power of 1 over 2. There is a 3 there. So you can substitute 3 followed by a negative divided by 3 followed by x positive 1 raised to the power of 1 over 2. So this is what you've got. On the left hand side you have got xy. So you can rewrite this as xy is equal to, now if you are placing root, now a raised to the power of n raised to the power of m is also rewritten as a raised to the power of m raised to the power of n. So you can bring x positive y raised to the power of 3 inside and put the square root as a cover. So divided by 3, and in this case you can just say root of x positive 1. Positive arbitrary constancy. So but this is not what is all just required. Okay, because we are expected to find the functional value f of 8. You see here, that is required. Now what I'm going to do is I'm going to put x is equal to 3 in. I'm going to take this as the original equation 1. Okay, and this is going to be my 2. So if I were to put x is equal to 3 in 1, what do I get? F of 3 positive 3 to 3, x is equal to 3, and f of t divided by t times dt is equal to root of 3 positive 1. Now this goes off, so you get f of 3 is equal to root of 4, which means f of 3 is equal to 2. So which in turn means when x is equal to 3, y is equal to 2. So you consider our 2. What is our 2? This is our 2. Alright. So you have xy is equal to root of x positive 1 raised to the power of 3 divided by 3 negative root of x positive 1 positive c. So you put x is equal to 3 and y is equal to 2 in 2. So this is our 2. So this is 3 of 2 is equal to root of x is equal to 3 positive 1 raised to the power of 3 divided by 3 negative root of 3 positive 1 plus c. Now this is going to be 4 raised to the power of 3. There is already a root of 2 there. So what I'm going to do is I'm going to write it like this. I'm going to take the root first and then cube it. This is absolutely acceptable. Now this is going to be root of 4 plus c. This is going to be 6. So root of 4 is 2. 2 raised to the power of 3 is 8. 8 over 3 negative 2 plus c is equal to 6. Now you can move this to the other side. You get 6 positive 2 is equal to 8 over 3 positive c. So that means 8 negative 8 over 3 is equal to c. 8 3s are 24. Negative 8 divided by 3 is equal to c. So from 24 you take away 18, or I would say take away 8. So you get C value to be as 16 over 3. Now C value is got. So once you get the C value, you can go and substitute it in the function. Okay. So what is the function from 2? We know, what do we know from 2? X times y is equal to, I will write this as root of x positive 1 raised to the power of 3 divided by 3 negative root of x positive 1. Now in place of C, I'll substitute 16 over 3. Now this is in terms of, or I would say we have a x there, so I want to push this x there. So this means y is equal to, I will bring 1 over x down like that and write this as root of x positive 1 raised to the power of 3 divided by 3 negative root of x positive 1 positive 16 over 3. Okay, but this is not the end of the solution. Why? So you see that they're asking us to find for x is equal to 8. So we need to get that x is equal to 8. So I need to go back, which is flip over. I will write the function. I need to write the function value. So f of x is equal to 1 over x of, you can write this as x positive 1 raised to the power of 3 over, is 3 over 2, right, whole cube. So I can just write as 3 over 2. 3 over 2 divided by 3 negative root of x positive 1 positive 16 over 3. This is what you got. So for x is equal to 8, we get. So what do we get for x is equal to 8? So f of x is equal to 8 is equal to 1 over 8 times x is equal to 8. So 8 positive 1 raised to the power of 3 over 2 divided by 3 negative root of 8 positive 1 positive 16 over 3. So this is equal to 1 over 8. This is 9, right? So I can write it as root of 9 raised to the power of 3 divided by 3. This is 9, root of 9 is going to be 3 positive 16 over 3. So this is 1 over 8, root of 9 is 3, 3 raised to the power of 3 is 27 divided by 3 negative 3 positive 16 over 3. So 3 divides here 9 times, 9 negative 3 will give you 6 positive 16 over 3 is equal to 1 over 8. So it's 1 over 8 of 3, 6 3s are 18 positive 16. Right. So this is equal to 8 times 3 is 24. This is going to be 20, 28, 34 divided by 24. This is nothing but f of 8. But we need 12 times f of 8. So it's going to be 12 times 34 over 24. This divides here 2 times. This divides here 17 times. Isn't it? So therefore 12 times f of 8 is equal to 17. Thank you everybody. Please like, share and subscribe.